There's a ball, stone we have projected. It will move in a parabolic path. Fine. This will take it. You can see all the things clearly. After some time, at t equals 0, ball is projected from the ground. Agreed. Then at t equals 0, we are projected with a speed u at an angle theta. After some time, it will be here. Just wait. And I'll redraw it. The highest point not needed. Yeah. After some time, the ball will be here. We are projected with a speed u. Then what is that position vector? I will indicate here. Are you seeing the difference between the path length and this one? This is the path length. I'll indicate separately. Or you can see this. This is a path length. This particular thing is position vector. Hope everyone getting some idea that R bar is what we have derived. Sir, what is that R bar you derived? Means this R bar what we derived. What all I derived, no? This R bar is this one. So what is there any difference between the path length? This one is a path length. This one is a position vector. Okay, then here we have two things. So then what is theta, sir? Theta is what with respect to the angle made by the velocity vector with horizontal. This is theta. Then this angle, what we call this angle, we'll call it as a angle of elevation. We'll define all the things. No? So what is theta? Theta will become angle of projection. What about phi is called as angle of elevation. How to define the angle of elevation? Again, the same formula. Tan phi is equal to y by x. What is y? U sine theta t minus gt square by 2. What about x? U cos theta into t. This will become tan theta minus gt by 2u cos theta. So there's a relation between the angle of elevation and angle of projection. Okay, this as usual maximum height. So we have defined the position vector, angle of elevation, this one. Next again, the distance of the projectile. The distance of projectile is time t from the point of projection is given by mod of r. This particular thing, this is called like a distance of the project. Means at what distance, at any time t, the projectile will be there. The ball or what you can say projectile will be there from the point of projection. This particular thing is what we'll call it as a distance. So already we know r bar vector. Modulus of this we have to take it. R bar is equal to, this will be u cos theta t whole square this will become distant position vector, distant. Okay, these are all the terms what we define for the projectile motion. Okay, kids. So this is the, so let me summarize the oblique projectile what we defined it here. Let me take this diagram. The person will kick the football. So he will impart the velocity u in this direction. He will impart velocity u. He will impart the velocity u at an angle theta. Then how the ball, because of the weight and velocity, it will move in a parabolic path. Then again because of weight and velocity, again it will move in a parabolic path. There's one basic idea of why it will move in a parabolic path. Okay, fine. Then as it moves in parabolic path, the weight, what it will do, it will decrease this vertical component of velocity. Then what will happen to horizontal component? Horizontal component, there is no force acting along x-axis. There's no force acting along x-axis. There's no force acting along x-axis. So therefore, the horizontal component remains same. Then when it moves from A to B, vertical component decreases, horizontal component remains same. Then when it moves from highest point to the point of striking, what should happen to the horizontal component? Again, it remains same. Whereas vertical component keeps on decreases.